So next topic is selection of preferred series or sizes. So what is this that we need to understand is what is the preferred sizes, then we'll see what is the preferred series. Okay, so the size of the product is a general term. So what is our topic? Selection of preferred size. What is the size comes, or size is the word to define certain dimension or thickness or shape, etc. But here the size is the general term. Okay, and certain examples of the general term size is: first, transmitting capacity, load carrying capacity, speed, etc. That can be called as a size. Second is height, length, width, volume. These geometrical property may also come under size. Similarly, weight of the product is also one of the example of size, because size is not only related to the dimensions, it is also related to the general term like transmitting capacity, load, power, etc., or weight of the product. So what is the preferred sizes and what is the use of these preferred sizes or preferred series, that we'll see now. Now these preferred series are first developed by Charles Renard in 19th century. He created five series: R5 series, R10 series, R20 series, R40 series, and R80 series for the selection of proper series. So in this case, preferred series are five. If you observe, R is the notation for series, 5 is the number. So what does R5 means? So R5 means fifth root of 10 is equal to 1.58. Second is R10. So R10 will be 10th root of 10. R20 is 20th root of 10. R40 is 40th root of 10. R80 is 80th root of 10, etc. Now if we see the number in the series R5 then R10, so 5 into 10, 5 into 2 10, 10 into 2 20, 20 into 2 40, and 40 into 2 80. So this is the number, that is R5 R10. Each time if we multiply by 2 to the number, we are getting the next size. And 5 basic series are R5, R10, R20, R14, R80. Now what is this R5? Fifth root of 10, which is 1.58. So in this case 1.58. So next thing or next number in R5 series is increased by 58% of the original value. In R10 series, 10th root of 10 is 1.26, so 26% is increase in the next number of the R10 series. R20 is 20th root of 10, which is equal to 1.12, which gives 12% of increase in the next number of the R20 series. Similarly for 40 and 80 series. After 80, if we consider R100 series, that is 100th root of 10 or 160th root of 10, that come very close to the 1. That's why we are considering these 5 series, that is R5, R10, R20, R40, and R80. One can say that, sir, why not R160? If we consider R160, mathematically it becomes 160th root of 10, which is equal to 1. So that number is equal to 1, and there is very less amount of increase in the next size. That's why to avoid very large sizes or very large variety of sizes, we are not increasing our series beyond R80. Fine. Now if we see basic series, there are two types of the preferred series or preferred sizes. Okay, so here I am calling it as preferred size, that can also be called as preferred series. So we can make this notation here: sizes or series, preferred sizes or series. Okay, fine. So there are basic two types of the preferred series. One is basic series and second one is the derived series. What is the basic series? Basic series is nothing but R5, R10, R20, R40, then R80, etc. Now one can easily see. Now see the R5 series. This first column R5. This first column is R5. Okay, this is the first column R5. So in this R5, if we see R5, this one, This is a continuous table. That means after the below this table, the second table and third table, this will be a continuous table. But due to lack of availability of the page, we are not considering. We are dividing one page into three pages. So below this second comes, and after joining these two, the third will come. So first R5. So R5 first number is 1. I have to go for number 1 to number 10 using different series, number 1 to number 10. So first of all, I will consider R5 series. So in the R5 means fifth root of 10, which is 1.58. So 1 into 1.58, I am getting 1.58, which is approximately 1.60 after rounding it off. 1.60 into 1.58, I am getting 2.5. 2.5 into 1.58, I am getting 4. 4 into 1.58, I am getting 6.3, and 6.3 into 1.58, I am getting 10. So one can see in the R5 series, I am getting 1, 2, okay, 1.6, 3, 4, 5, and 6. In R5 series, I can reach from 1 to 10 in 5 subsequent series. That is 1 to 1.6, 1.6 to 2.5, 2.5 to 4, 4 to 6.3, and 6.3 to 10. Now we will see the R10 series. First number in the R10 series is suppose 10. So 10 into 10th root of 10. So what is the 10th root of 10? 10th root of 10 is 1.25. So 1 into 1.25 is 1.25. Next number 1.25 into 1.25 will be 1.6. 1.6 into 1.25 2. 2 into 1.25 2.5. 2.5 into 1.25 3.15. 3.15 into 1.25 4. 4 into 1.25 5. 5 into 1.25 6.3, and 6.3 into 1.25 is 8. 8 into 1.25 will give the value 10. So here in R10 series, to go from 1 to 10, I have to go from 1 2 3 4 5 6 7 8 9 10 11. After 11th iteration, or after 11th multiplication, I am getting 10. Now for R20 series, from 1 to 10, I have to go for 1, okay, 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21. In 21st number, I am getting R20 series. In R40 series, to go from 1 to 10, I have to go for 1 2 3 4 5 6 7 8 9 10 11 12 30 40 50 60 70, whatever. If we count this, we are going to get 10 after. So from 1 to 10 using R40 series will take large time. Hope you understood. Second is derived series. Derived series, okay, derived series is basically uh, derived from the basic series itself. Okay, derived series are basically derived from the basic series. So derived series is designed by or designated by a symbol of the basic series followed by number 2 3 4 or p, and separated by symbol backslash sign. So divided sign is there. Okay, example R10 by 3 in bracket 1 to 1000. So what does it mean? R10 by 3 1 to 1000. So this total term R10 by 3 1 to 1000 indicates, okay, indicates, I will erase this, indicates R1 10 by 3 1 to 1000. It indicates derived series comprising of every third element of R10 series and having the lower limit of 1 and higher limit of 1000. That means from 1 to 1000, if I have to make a series, each third term will be R10. Each third term will be of R10 series. Okay. Next, we'll see the example of series. Okay.